So you can create new functions by adding functions together, subtracting functions, multiplying functions, or dividing functions. You can also create new functions by putting them together in composition, creating what we call composite functions. Now the notation for a composite function looks like this. And the way you read that is f of g of x. I personally like to write my composition of functions this way, so it's very, very clear when you look at it in this notation that what I'm doing is I'm taking the equation for g of x and I am plugging that into the function f. So to look at an example, suppose function f of x is 5x plus 6 and function g of x is 2x squared minus x minus 1. The composite function f of g of x, I would begin by writing f of g of x this way. Okay, and then I'm going to replace g with what g is equal to. G is equal to 2x squared minus x minus 1. So now it's very clear that what I'm going to do is take the quantity 2x squared minus x minus 1 and put it in function f. Well, function f is 5 times your variable plus 6. So put in a set of parentheses to hold the space. And in that set of parentheses, put in 2x squared minus x minus 1. And then clean that up. So we're looking at 10x squared minus 5x plus 1 when you put everything together. That is our composite function, f of g of x. The domain for that function would have to be all real numbers. Now that partly comes from looking at what we got when we composed the function. It also comes from thinking about the domain for the pieces. Anytime, and you're going to find that this is true, anytime you have a polynomial function, the domain is all real numbers. So you kind of have to think about domain first. What goes into g of x? Well, any real number is going to be okay to go into g of x. And then you think about what goes into f of x. Well, any real number is going to be okay to go into f of x. So any real number would be okay for the composition f of g of x. Now, it is interesting to note, and important actually to note, that if we worked the composite in the other order, in other words, let's now look at the composition g of f of x. Okay. Now I'm kind of going to work you through this a slightly different way. Function g is 2 times your variable squared minus the variable minus 1. Okay, let me scroll back up and make sure I got the right function g. 2x squared minus x minus 1. So in that equation for g, I've put a set of parentheses everywhere there's an x. And in that set of parentheses, we put f of x. Then in my next step, I'm going to replace f of x with what it is equal to. F of x is equal to 5x plus 6. And then you simplify. And these numbers are going to get a little big, but that's okay. Distribute the negative, and then distributing the 2 and adding like terms, we're going to have 50x squared plus 120x plus 72 minus 5x minus 6 minus 1, or 50x squared plus 115x plus 65. And that is our function g of f of x. the domain for this polynomials, all of it, so negative infinity to infinity. Now notice what we got for g of f of x. Very, very, very different from what we got for f of g of x. So the order that you put functions together in composition matters big time.